So, hello everyone. Today's question is let's reset the timer. Start it. Minimum recolors to get k consecutive black blocks. You're given a zero index string. It is named as blocks. It's of length n, and the index blocks of I represents either a character W or P, and W represents white color and B represents black color. Okay. You're given an integer k. So you're given an integer known as k. You need to determine consecutive, which is the desired number of black blocks, consecutive black blocks. So k represents the desired number of consecutive black blocks that you need to obtain. And in order to obtain such black blocks, you need to do some operations. And at max in one operation, you can at max recolor a single white block to become a black block. So for one operation, for one operation, a white block becomes a black block. So for a specific operation, a white block becomes a black block. And now we need to figure out the minimum number of operations that we need to do in order to obtain the k consecutive black blocks. Now let's see this string as an example. So in this string, the desired number of black blocks or consecutive black blocks are 7. So we need to obtain 7 Bs. And here we have white, black, black, white, white, black, black, white, black. So here we have 1, 2, 3, 4, 5 Bs. If we convert these two, we get C. Do this operation. Remove these two whites, this white and this white. This white and this white. We did two operations. So now it is 1, 2, 3, 4, 5, 6 Bs. And you also remove another W, which costs you instead you can also make change of this W, which makes 1, 2, 3, 4, 5, 6, 7 Bs. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. So you need to figure out the minimum number of operations that you need to do so that you can get at least one occurrence of such consecutive k consecutive black blocks. Now let us figure out the minimum. In order to figure out the minimum operations, let's do one thing. The thing is, we need to uh, let's see this. One way to achieve 7 consecutive black blocks is to recolor the 0, 3rd, and 4th blocks so that the blocks here the blocks will be like this. It can be shown that there is no way to achieve 7 consecutive black blocks in less than 3 operations. Therefore, we return 3. Okay, blocks. Here it is WB, WBB. We require 2 consistent black box. Already we have 3 consecutive black blocks. So the output would be 0. No additional changes need to be made since we already have 2 consecutive black blocks. Now let's check how we can do this question. The thing is, okay, we have a string. Hmm. W B B W W B B W B W. Here, let's note the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the indexes of W are, what are the indexes of W? 0, 0, 3, 4, 0, 3, 4, 7, 9. These are the indexes of white block. So we can do one thing. we need to figure out the minimum number of indexes need to be changed. See, mm, we use a variable to track number of black blocks. Okay, int bc bbc black block count. This will track number. This will track what? It will track number of consecutive black blocks obtained. Okay, variable to track number of consecutive black blocks obtained. And here, let's remove this. Now, let's use a for loop. For, let's iterate over this. Int I is equals to 0, I less than blocks dot length I plus plus. Okay, what would be the case first? Let's check. If s dot char at I equals to b, if it is equals to b, then what do we need to do? bbc plus plus. Next, if it's not a b, if it's a w encountered, if else, I mean else, what we can do is, so if it's not a black block, it's a white block, what we can do? We can do one thing. We convert this, convert white block to black, then update count. Check if it obtains max required KB black blocks. See, let's see if this is happening. I mean, if let's check this. We actually you took figured this W, we converted this into black. If this is that, I mean, black box count. We'll do this long-term black box count or global count, global black box count. This is local black box count. Int local black box count. Int local black. Okay. Here we also describe this int local black box count equals to 0. Now, if the global black box count, wait a minute, in the local black box count, we can figure out that it's not actually, see, if we make a W as B, we can actually update, the local black box count. So basically here, let's look into this. Uh, we first took, obtained a W. If s dot character equals to W, okay, we do one thing. We figured out that it's W. Okay, now in this case it is W. What we did, we flipped it. When we flipped it, we what we do? BBC local black box count is equals to plus equals to 1. So we added 1 to it. Local black box count. If s dot character count. See, we have options to choose. There are W here, here. W is here, here, and here. We can choose any of these here. So first we flipped this. The count that we obtained is 2. and then again we flip this, then the count obtained is this. So when we did this, we figured out that after flipping, uh, the minimum number of flips required is just 2, since the minimum required number is already satisfied. So we can do one thing. We can track number of B's we got. Okay, so let's track this. Global black block count will be 0. When a B is encountered, we update this global black box count. Okay, otherwise let's make it BBC, that doesn't matter. So whenever we have, I mean, in resultant operations, we make this as resultant operations is 0. Whenever we obtain a new thing, what we do? We update result, we'll count the local black box count, sorry, just a black box count as 1. Now, if, hmm, okay, let's do this. If the black box count is updated, what do we also check? We need to also check if black box count equals to k. Then, if in any case this equals to k, the required number, then we can directly return the result. If it is obtained, if it is directly b, we just need to count it. Otherwise, no. So else if w obtains, then we are definitely changing this. What if we consider this? We change it this. It's 3 b's now. Change it this. We changed this. Now it's actually, so we stopped it here. So I guess this will work. Let's run this, guys. Mm, No, I haven't used a return statement here. That makes no sense. Return result. Let's reload the page again. Mm, Wi-Fi. Let's shoot blocks dot get notice Wi-Fi. Okay, this is one more error. Output is 7, but expected is 3. So we need to track the number of operations. If it is equals to k, we return. Um, k is 7. Output should be 3. But what's happening? We're returning output should be 2, expected as 0. Okay, let's look into this. Hmm. See guys, in this case, k equals 7. The output is 7 obtained here. So we change this W, calculate this, we change this W. Whenever a W is changed into hmm, if the number of blocks obtained consecutive blocks should equal to k. So when I equals 0, I less than blocks dot length, I plus plus if blocks count equals to k, then we just return it. So it's initially 0 and k is 7. So this won't work. Else if we blocks dot caret I is b. No, it's not b here. So black box count is not updated is equals to bbc plus 1. Result equals to result plus 1 since we're converting w into b, and then black box count is obtained. Yeah, let's run this again. I think there's no issue in this code. The output is 7. Hmm. Result equals to result plus 1 equals to that block. Okay, let's take this. If black box count equals to k, then we're returning the result. Else, if black blocks dot char at I equals to okay, we do one thing. What we had done, we'll just return black box count. We can figure out how much we got at least. Let's debug this code. The output that we are getting is 7. So the black box count is 7. That's okay. Yeah, simply equals to z plus 1. Now, black box, if black box count equals to k, then we're returning the result. Initially, the black box count is 0, the result is 0. If a black box count equals to the given consecutive integer, we're just returning the result, which is actually 0 here. Else, if if blocks.caret equals to b, it means that a b is encountered, so we need to add it. Else, if a w is encountered, we're changing it, and then since we are changing it, cost 1 operation, so result is updated to 1, and black box count will be updated by 1. And then we return the black box count. Hmm, Result equals result plus 1 and the loop. We want to return result.
చేస్తా ఒక్క నిమిషం మళ్ళీ టైం అయిపోతుంది సబ్మిట్ చేయాలి లేకపోతే మార్కులు రాసా
So this basically involves this. Check the editorial today. How much time? This involves sliding window actually. Let me check what's wrong in this using ChatGPT. Incorrect approach. You need to find the minimum number of operations to get k consecutive instead of counting BPC directly. Using a sliding window to count the number of white blocks in a fixed window size. Double logic increments BBC and stops when BBC equals to k. But this doesn't ensure that the k consecutive blocks are together. Incorrect character check. But the problem is uppercase B and W. Oh my god. If that's the case, let's change this. So that's an issue here. Even then, sliding window is a new concept that I haven't done. So let me just update this for a while. I don't know how to. Let's run this sliding window. So sliding window is a variation of two pointers approach where we count the left and right and then we use that. So this is giving us compile time error. Let's check what the issue with this is.
అమ్మా చేస్తా ఎండింగ్ లో ఉందమ్మా చేస్తా
Yeah. Now, yeah, this got submitted. That's it, guys.